This is Dave Spicer, and I'm here to speak with you about IdentityJS, a new way to develop applications end-to-end in standards, where the standards are JavaScript, HTML, and CSS. And it means standards on both the client and the server to reduce your system development and maintenance costs by a factor of 10 and focus on your applications, not the infrastructure to build them. To get the full story on IdentityJS, go to IdentityJS.com. Today we're going to be focusing on Identity Cloud over on the right side here. There's a previous video done that focused on Identity Client, and I'll provide the URL for that below. When we look at systems in the current time frame, the 21st century and probably beyond, they're really broken into two pieces. You have clients technology on the left and server technology on the right. And the clients typically include I/O devices like smartphones, both Android and iPhone. And in the future, Microsoft WP8 will probably be there. Browsers, both desktop and smartphone. On the server side, we have private and public. In the private category, you might have IoT, Internet of Things devices, or corporate machines. In the public domain, you would have commercial cloud vendors like Amazon AWT, Microsoft Azure, IBM, Google, and Oracle. Today we're going to focus on the server side and talk about Identity Cloud. Identity Cloud is a pre-configured Redis Express Node.js cluster that installs in 5 minutes and runs on anything. Runs on Mac and Windows, usually for development. Runs on Linux, usually for production, although it could be used for development. Runs on IoT devices with embedded Linux, or any commercial cloud vendor that you saw in the other diagram. What this means is you no longer need a web application server. That's built into IdentityJS because of Node.js, which means in 5 minutes you can have a web server running and start building your application. It comes with integrated web services infrastructure that marshal native JavaScript objects of arbitrary complexity, and is developed as a portable platform as a service layer, which means existing apps can be migrated between environments, for example, between cloud vendors, or between private deploys and public deploys. Up to you. As we get through this, we'll actually install the Identity Cloud on a Linux box and put it through its paces. Before we get too far into the weeds, let's review some key architectural concepts. Identity Cloud is inspired by graph theory, where a graph is a set of nodes connected by edges. So Identity Cloud is actually a set or a graph of identity nodes connected by edges where the edges are themselves web services. It's an open and extensible architecture because it's developed in standards, and it's object-oriented JavaScript with one helper function, simple design pattern, and it's the same technology for both clients and servers. It also has built-in JavaScript web services infrastructure, which provides marshaling of JavaScript from JSON to JavaScript and back again, at least once for idempotent types of services and only one semantics for those that are more strict. It supports software by reference, so like synchronized data, IdentityJS synchronizes your code across all platforms, making it accessible by reference from a centrally managed URL. And it's all based on recursion, so IdentityJS is built from itself, meaning it employs software by reference, employs its own web services internally. So let's look at Identity Cloud in the traditional layered fashion. And Identity Cloud runs as a portable platform as a service. It can be installed on any cloud vendor's infrastructure layer, or of course can be installed on private devices, corporate devices, IoT devices. It's the same platform in all cases. What's unique here is it's portable and it can be moved from one to the other. And as I said, each node is a container on which you can run multiple applications. So as you see in the picture here, we have the identity platform as a service in which we're running multiple applications in the application layer. And then when it comes time to move it, you simply can pick up from one vendor. If this was a cloud vendor, you could pick it up from vendor A and move that to cloud vendor B. Of course, you'd have to export your databases and things like that, but your code would not have to move at all because your code is actually sitting on a code server, which is just a URL that would be the same regardless of whether you're running on vendor A, vendor B, on an IoT device, or any other device. We need to spend a few minutes on object-oriented JavaScript because we'll be referencing it later. JavaScript supports objects as a native type, but there's no language support for the object paradigm that would accommodate inheritance or polymorphism or other object syntax that we're all familiar with. But that can be overcome with a simple helper function and a simple design pattern that uses that helper function. So here is that helper function, and it's in the library. Basically 4 lines of code that allows a subclass to extend a base class. And down here, we're going to have, as an example, we're going to have 3 classes. This is class A, which is a base class, has a couple methods in it called init. This one's called getFoo, and this one is called setFoo. And then down here, if we scroll further down, we'll have another class called B. And as you can see up here, B extends A. So A is the base class, and B now extends A. So when we create a new B in the constructor, this is the pattern we use, and this is a way to invoke the base class constructor. So basically we're telling JavaScript to invoke my base class and pass it myself. And again, it would be nice if JavaScript had a syntax to do this, but it's not really necessary. It's a pretty simple pattern. And here we have methods now that will override the methods in the base class, but of course can invoke those methods in the base class. So let's say init in class B wants to invoke init in the base class. This is the pattern for that. Basically, I'm saying B invoke the base class init, passing this itself and the params that were passed in. And then here's an example of a class C, where C extends B, which means it also extends A. So, and you can build these up to any level you like. So basically, with a simple helper function and a design pattern, we can have everything we need to have an object-oriented environment built into JavaScript. Now let's look at the process architecture of Identity Cloud. Identity Cloud comes with a pre-configured Redis Node.js Express cluster that is packaged in a simple jar file that can either be unjarred or unzipped on the server in which you want to install it. The standard way to cluster Node.js is shown here on the left-hand side. Basically, you have a master process which forks off multiple workers, as many as you need, up to worker n, as I show. And then each worker does its bit while the master sits there waiting for them to end. What's different about Node.js is it comes packaged with a Redis database capability, and the masters are able to do work while the workers are working. So in other words, you have work that the master can do other than just sitting idle. It can actually be running tasks that are programmed as task objects that are running in the background, doing common work while the workers are actually processing transactions from the network. And what happens is you typically run into the case where you need to share state information between processes, because these are actual processes, not threads. They all run in their own address space. And so there's occasionally time when you need to communicate state information between the workers. So a worker could begin a transaction and maybe gets retried, but when it's retried, it's handled by another worker. But of course, they need access to the state information from the first interaction. So you need something to handle state, shared state And in this case, what we've selected is the Redis database. It's an in-memory database. It's incredibly fast. It's an object store database. So it works nicely with JavaScript objects. And this is what comes packaged with Identity Cloud. Okay, so now let's install Identity Cloud on a real device. In this case, it's a small Linux machine I happen to use for development. I have two windows open on my desktop here, both going to a machine called Hubbub Dev. And again, this is a small Linux box. I'm going to use this window here, and let's just do ls-l and see what's currently in the root directory. And what you see here is I've already got an instance of Identity Cloud running. It's running on port 3450. The nice thing about Identity Cloud is I can run multiple nodes on the same machine. Now, why would this be useful? Well, again, Identity Cloud is based on the mathematical idea of graph theory. And so I can create a network of nodes on the same machine for testing or for demonstration purposes, even though if in production they might be on separate machines. So again, there is a good reason to have the ability to do multiple identity nodes on the same machine. I want to do a new one now so I can demonstrate what it takes to install identity node on a machine. So the first thing I'm going to do is make a directory called Identity 3451. Well, we'll use port 3451 this time, so it's listening to a port separate from the one we currently have. And there it is. Now what I'll do is look in my stage copy directory, and you'll see in red there is my Identity Cloud jar file. So I've already got it staged here in my target machine. And what I'm going to do now is place a copy of that in the new directory I created. And then we'll expand it and go from there. Okay, so we've got the jar file for Identity Cloud sitting in this new directory. Now we're going to expand it. We can either use jar to do that or unzip. Since this is a Linux box, I'm going to use jar and say jar xf. And since that's the only jar file, and here's what it created. So it created a directory called Identity Cloud, and that's where all of our technology is now sitting. Before we go any further, I should also tell you I've already installed Node, Node.js, and Redis. So let's show those. So I'm looking for the process node, and here it is. So this is from the currently running node I have on port 3450, and you can see that right here. So basically there's three processes which correspond to the master, and these are two of the worker processes. So I've got a cluster running right here as identity node running on port 3450. The other thing is we do need Redis running, and I've already got that installed, and it's listening on port 6379, which is its standard default. So again, Redis is the in-memory database that we use for sharing state between running processes in the cluster, and all of that technology comes with. Of course, you do have to install Redis separately, and it's running right here now. And you can share Redis with any other applications. Every identity node runs in its own namespace in Redis. So I'm going to be sharing this particular Redis installation with the existing identity node that's already running on 3450. So now let's look at what's inside Identity Cloud. And we see three directories: Identity App, Identity Fixed, and Identity Node. Identity App is where I put all my application-specific classes. Identity Node is where I put all of my packages that are pre-installed. So let's go look at Identity Node. And if I look at the modules, node modules, you can see here are the modules that were pre-packaged. And what's important here is these are modules that are running versions that are all compatible. So I don't want the system to automatically upgrade, which I could do with the Node Package Manager if I wanted, but I want them to run these particular versions that I've packaged because I know they're all compatible. Now there's one exception to this rule, and that is, so I don't have to build any except with the URSA package. URSA is the RSA package, which includes some C code, which means I can't just arbitrarily package it up and send it to somebody. Depending on the platform they're on, they'll have to do an npm install of URSA. So I'll do that now while I'm in this directory. And it just takes a minute. Here it goes. So you see it's using no JIP there, so that tells you there's some C code in here. And it'll take a second to complete. There we have it. Okay, so now we have everything installed. The only thing that remains is to set up our configuration file. So if I go to Identity App Directory, this is where my app-specific information is, I can look at my JSON configuration file. I'll just use Emacs here, my favorite editor, at least command line editor. And here I have to make a few changes. So my listening host is not that. This Hubbub dev machine is on 192.168.1.21. And we're listening on port 3451, not the default. And we're going to say we're listening on HTTP. Workers per core is set to 1. So if we have, this machine happens to have 2 cores, so we should end up with 2 workers when we get done. It tells us where the Redis host is at, which means it's running on the local machine, and Redis is listening to the default port of 6379. So now we've got a configuration file. It's that easy. So I'm going to save this thing. So there's my configuration file. So now what I want to do is set up my job control. Linux systems include something called Upstart, which is a job control system, which we can conveniently use to start and stop Identity Cloud, or the nodes within a cloud. So let's see where we're at here. And you can see I have Linux Upstart scripts. So let's go there. And take a look at the identity node conf file. This one right here. And we're going to have to edit that one and save it in the appropriate place. So let's use Emacs again, and what we need to do here is change this from 3450 to 3451 to go to the correct directory. And then we have another instance of this because we want it to go, we want to save all of our logging information to a log file that Upstart provides. So we're going to change that to 3451 as well. Now we're going to save this file to /etc/init/identity node 3451.conf. So that's the naming convention for Upstart, so we can start and stop this this whole set of processes. So now next step is to go to the logging directory, which is for Upstart is var log, and let's do an ls-l. Let's see what log files we have in there for identity. Okay, so this is is the log file for the node running at 3450. We need to create one for an empty one for 3451. So I'll do that like this and just create a file. It'll be empty for now. But now I can do a tail. So now what I want to be able to do in this window is monitor the output as it's going to the log. Right, and right now, of course, the node at 3451 isn't running. So that's what we're going to do up here. So now we're going to use upstart. I'm going to say start identity node 3451. And when I do that, we should get some output in this file, and we are getting a lot of it. So it looks like we're getting more output than we'd like, and we'll fix that in a moment. But at least it's showing us that the node is running and producing the logging output we'd expect. The next test here is to validate that we can reach this node. It's an addressable IP address, and also we need to have some means of controlling it, a console of some kind. Fortunately, both those things can be done with one step here. It turns out that Identity Cloud has a built-in identity client called console. So if I go to 192.168.1.21 and it's on port 3451 console, we should get something that looks like this. So now we know we're running the console that's actually running from the node that we just installed. So the first step now is we have a working node. If we hit the login button here, we want to assign an admin password, and we need to do that so we can manage this whole node itself. So we have an admin ID, and the first person who gets here, who has installed it, should assign a password. I'm going to do a very easy one. And now it's going to force me to enter my admin information, which is not a bad idea. So here's my password. I'm going to put my name in here. And again, this is an identity app now. It's being run with Identity Cloud. I'll put in my real email address here. And I'll submit that. Okay, so now we've noticed I'm logged in as admin, but I haven't yet given this a name. Let's go check my email real quick. And by the way, Identity Cloud includes an email server, so that it was able to send me a notification that I had changed. In this case, I had initialized my user profile. So what's handy here is in your application, you have access to an email server to use as you need for your application to notify people via email or of any events or for any other purposes you can think of. So let's go back to the console, and you'll see it is an identity application because here's my home menu, my profile, publishers, my services, library releases, dev controls, things like that. And if I hit log out, it all erases that, and I'm back to just my home screen. I'm going to log in again, this time as admin, because that's the only ID I set up so far, the password I just established. And one of the things we can do here in the dev controls is set up our logging levels. Remember, it was chattering a bit much, and so what we want to do is quiet it down a bit. And these are the logging levels. Level 2 is usually used for debugging, so I'm going to just log at levels 0 and 1. So I'm going to do that and submit it. And now if I go back to my screen, you'll see I updated my log levels to 01, which is going to quiet this whole thing down a whole lot. And again, what the console can do is when a developer is working, they can turn on and off the debugging level. And as the situation warrants, they may want to see all the detail, they may not, and they can control that themselves from the console. Okay, so let's log out here. And next thing I want to do is show that this works just as well from my iPhone. So this is my real iPhone. I'm just using some mirroring software to put it on the same screen. If I go to Safari, and we'll go to the same IP address, 192.168. Go to the console. There you have it. So you can see we're running the exact same software on my phone now. What I want to do now is I'll log in again, this time from my phone. Now what I want to do is I'll close this window and I want to assign this machine a name. And I'll give it the name, first I'll edit, and I'll give it the name ID test node. So we've seen Identity Cloud running on one of the smallest environments, a small Linux machine. Now let's look at the other end of the scale. What about one of the largest would be the Amazon AWS environment. This is a commercial cloud vendor and probably the most prominent. And if you look at this URL here, what you see is it's connected to the identity client is now connected to Identity Cloud node at this location, which is an Amazon AWS virtual private cloud. And this is about as large as they come. Let's go ahead and hit refresh here and watch what happens. And of course, we're are running just fine on that cloud. And again, it's the very same software. In fact, it's running the same software on the same code server. So any changes made to the cloud technology is actually made to all instances of the cloud technology, regardless of where they're running. Now let's do one more test. As we said, IdentityJS is hosted by itself. It's actually running on its own technology. So let's go to the production site. We'll go to IdentityJS.com. And this is the production site for IdentityJS, website and application. And if it's true that it is running on its own technology, it's running as an app, then it ought to be true that there's a console associated with this node as well. And we can show that by going up here to the address bar. And we'll try going to the console now at the same address. And sure enough, there it is. So there's actually two applications running on this identity node. One is the console you see here, and the other is IdentityJS, which is the application running on itself. So let's just log in to prove that, and log in as admin. And there you have it. So now let's finish with kind of an end-to-end test of Identity Client and Identity Cloud. And the thing that ties them together is web services. And the unique thing about IdentityJS web services is that they are first integrated, and second, they are guaranteed delivery. So that when untoward things happen between your device and the server, your application doesn't need to know that. The semantics of your application are the same as if it always worked. And our infrastructure will take care of the actual retransmissions and guaranteeing that the results get through. So let's look at a simple test. We're back to my phone now. And if I were to press the name tag in the upper left corner to get the actual name of this node, it's actually running a web service to get that information. And what you see here is the results of that. So if I go back home now and try to emulate a bad network connection, that would be difficult. It's actually easier to get the same results, and that's to go to my running node that we just installed on my small Linux box. So we're going to stop this node from running. And as you see down here, both workers have exited and the master has exited when they finished. And now we're going to go and try our web service again. I'll press the name field in the upper left corner to get to that next screen. And what you see now is it's working to get it. And if you look in the upper center of the screen, we're doing retransmissions and, of course, not getting through. So now what we need to do is restart the node. And down here you'll see it starting up. And after it does, what you'll see is the phone will now catch up and ran the transaction as if the interruption had never occurred. So there you have it. End-to-end, new technology can reduce your system development cost and maintenance cost by a factor of 10. Thank you for watching.